Hello students of the 12th class physics, this is your video number 13 and heading continuous charge distribution. In the last videos I explained you about the various things of the electrical charges, forces and field, electrical dipole moment and electric field due to the various electric dipole positions like axial positions, like equatorial position you can see in the last videos. Okay, in the recent video I explained you about the electric flux, and before telling you about the Gauss theorem I want to tell you about the what is continuous charge distribution. Okay students, so I am going to tell you. Suppose there are charges q1, q2, qn. There are so many charges and they are separated by a distance. So this is called discrete charge distribution. Discrete word. Okay, what is the word? I am going to write one more time. Discrete charge distribution. Okay, what is continuous charge distribution? I am going to tell you. Okay, suppose there is a region, okay, and charges are present everywhere, plus charge or minus charge, everywhere, even in the microscopic distance also. Okay, so if it is not free anywhere, all this orange color is actually charge, whether plus or minus. Okay, I'm going to fill it. Okay, so almost this is a continuous charge distribution, and at this point at which I can calculate the electric field. This is the continuous charge distribution. Okay, but before that, in all headings, what I told you about the discrete charge distribution, q1, q2, qn, and there was a point P at which we calculated electric field due to q1, q2, qn, and so on. Okay students, I hope you have understand what is continuous charge distribution and what is discrete charge distribution. Okay, I'm going to read you for this. This is your heading in video 13, continuous charge distribution after electric flux. So far we have discussed about the charge configuration involving discrete charges q1, q2, qn. Okay, in the next page I will tell you everything. Okay, this is your next page. Okay, this is the next page of your this video involving discrete charge. I told you earlier, this is the figure I told you, but look at the video part. q1, q2, q3 and qn. This is the discrete charge distribution, but I told you about the continuous charge distribution, where in any region or area overall charge is present everywhere. Charge is present. Overall is not the good word. Okay, and this is the charge, and at any point P I want to calculate the electric field. Okay, so this is the continuous charge distribution. So I am going to read it for you. Now we will discuss three types of continuous charge distribution. Okay, this is three types. What is, as I told you in the 11th class, there is one dimension, there are two dimensions, and there are three dimensions. So on the basis of these three dimensions, there are three types of charge distribution. One, as you can see in your video, is linear charge density, which represents the linear charge distribution. What it represents? Linear charge distribution. Okay, so linear charge distribution, student, is represented by your heading A. This is your heading 10A. I'm going to show you one more time. Look, this is your heading number 10A. Okay, 10A, and this is linear charge density, which measures the linear charge distribution. Why linear? Because I am starting from the one dimensional charge distribution, which is continuous charge distribution. Now look at the video. This is a type of one dimension where charges are present continuously, distributed continuously. The whole length is L, suppose, and the whole discharge is Q. But as I told you so many times in 11th and so many times in the previous videos of this chapter, that charges or something big, I will start from the small. What is small? There is a very small length dl where dq charge is present. Okay students, so there are bigger charge and I am taking the small part of that one dimensional charge distribution, which is measured by the linear charge density. I hope you understand this video. Okay student, so I am going to read it for you. Linear charge density. In figure 10b, you see the whole length L where whole charge Q is present and the small part of that dl length in which dq charge is present. Okay, now come to the original video. I am going to read it. In figure 10b, uniform continuous linear charge distribution is present. Okay, the word is clear to you. Now go further. Now come to the next mathematical term. If lambda is the uniform linear charge density, is it easy to grasp? It is total charge Q by length. Okay, I'm going to show you one more time what you see in this video, student. This is your lambda. It is familiar term. So many times you have used in the previous classes. This is the term used to measure wavelength of wave, but this time not the wavelength of wave. This is used to measure uniform linear charge density. What is uniform linear charge density? Total charge Q upon length L. Okay, so this point is clear. What is 2? If I will take very small distance dl, as I told you in the figure, what would be charge there? dq. So dq by dl is also a lambda if I am taking very small charge dq for the very small linear charge distribution dl. Okay, so there are two formulas, but both are calculating same value because there is uniform linear charge density. Lambda is q by l for whole charge and whole length, and lambda is equal to dq by dl for very small charge and very small length. And what is SI unit? SI unit is easy to grasp by you student. Charge SI unit is coulomb and length SI unit is meter. So the SI unit is coulomb per meter. Okay, so this is the linear charge distribution measures by linear charge density. I am going further to the 10th P. What is this heading? Surface charge density. It represents two-dimensional charge distribution, continuous charge distribution, not discrete. I am telling you in this heading we are discussing only about the continuous charge distribution. What is continuous charge distribution? I told you so many times in this video. Okay students, so look at this. There is any surface area, maybe regular, maybe irregular. Whole charge is Q there and whole area is S. Okay, but you see there is very small area ds in which very small dq charge is present, just like we did in the previous heading of uniform linear charge distribution, which was measured by the linear charge density, but this is measured by surface charge density or surface charge distribution. Okay, come to the original video. I'm going to read it for you. This is your surface charge density in figure 10c, as you are seeing there. Okay, uniform continuous surface charge distribution present. Okay, sigma is represents the surface charge density. Okay, come to the original video and come to the next page. Okay, I'm going to tell you what is sigma. This is sigma. Okay, this is the notation which measures the uniform surface charge density. Okay, just like the lambda, it is defined as lambda sigma is equal to total charge upon total area, and if you are taking very small dq, very small ds area, then lambda is for bigger charge by bigger area, and lambda is also very infinitesimally small charge by very infinitesimally small area. Okay, what is SI unit of that? Q is in coulomb and surface area in meter square. So SI unit of the sigma is coulomb meter minus 2. Okay, now come to the third kind of uniform charge distribution, that is, okay student, as you can see I am going to show you what is that. That is volume charge density. You are seeing the whole volume V where the total charge Q is present, and the small volume I am also taking where dq volume and dq charges are present. As I told you, for bigger as well as for the smaller one I am calculating. Okay, I am going to read it. Volume charge density In figure 10d, uniform continuous volume charge distribution is present. Okay, now come to the next video, next part of this video. Yes, student, come closer. Yes, if rho is your, just like this. Okay, if rho is uniform volume charge density, just like we calculated lambda, just like we calculated sigma, lambda for the uniform linear charge density and sigma for the uniform surface charge density, and now rho is for the uniform volume charge density. Okay, clear, student? Okay, and what is rho? Total charge by total volume, or if I am taking very small charge by small volume. Both are clear to you, just like lambda and sigma. What is the SI unit of rho? The SI unit of sigma is Q coulomb, and volume SI unit is meter minus 3. So coulomb meter minus 3 is the SI unit of rho. Okay, student, in this video number 13, I told you about the various aspects of continuous charge distribution. What is the difference between continuous charge distribution and the discrete charge distribution? And in the next video I will tell you about the Gauss theorem. So I am going to finish this video number 13, which tells you about the continuous charge distribution.